Good morning, everybody. First, let me thank very much the organizer for inviting me. My name is Jean-Francois Lecomte from the French Institute for Radiological Protection and Nuclear Safety, and also member of ICRP, the International Commission on Radiological Protection. My talk is related to the ICRP approach for the protection from the naturally occurring radioactive materials exposure, the norm exposure. This issue is the subject of publication 142, which was published in 2019. As you know, there is a wide range of industrial processes, including norm, mining and extractive industries, production of coal, oil and gas, production and use of diverse metals, phosphate industry, water treatment, cement production, building material, etc. Here are some characteristics of these industries. They are generally identified, they are very diverse, already ongoing. Generally, they are big-size industries, but they are not one sector in itself. They are generally subject to authorization, but not for radiological protection. They have experience in risk management, but generally a poor radiological protection culture. The norm is ubiquity. There is a variability of exposure. These industries may pose an issue of environmental contaminations. Here is a figure showing the big element of this ICRP system of protection. In the middle, you have the three principles of protection: justification, optimization, limitation. And these principles are applied in different exposure situations for different categories of exposure, using different dose criteria, and for the implementation of different requisites. About industries involving norm. ICRP considers that norm is an existing exposure situation. It was clearly stated in publication 103. Why? Because norm already exists when a process is starting, and norm may be deliberately introduced in the industrial process, but not for its radioactive properties. Otherwise, it is a planned exposure situation. And the process in which norm is concentrated is mainly incidental. Further, because of other characteristics of industries involving norm, there is a room for an integrated and graded approach. Often, there are multi-hazards industries, and the radiological risk is rarely dominant. It is a challenge for the integrating of both types of management for radiological and non-radiological hazards. With norm, there is no real prospect of emergency leading to tissue reaction or immediate danger of life. Another characteristic is the fact that exposure can be anticipated, but its detailed level cannot without a characterization. And there is also a limited option for management of residues and waste compared to planned exposure situation. About categories of exposure, processes involving norm may lead to occupational exposure, taking into account that not all workers will be considered as occupationally exposed. It could lead to public exposure and also to environmental exposure. About the implementation of the principles. Justification is applied to the protection strategy, even in case of a new process. After characterization, and it is recommended to set a national list of industries involving norm able to be justified. Optimization is the driving principle. It is implemented in norm in the same way as for other industries, taking into account prevailing circumstances, keeping in mind that options may be more limited. The principle of dose limitation is not relevant a priori. Anyway, there is a flexibility, and this principle may be applied for regulatory purposes. Now, let's see what are the recommendations for the protection of workers. As said, it is recommended to adopt an approach both integrated and graded. This approach is starting with the characterization of the exposure situation and integrating, as necessary, specific radiological protective action to complement the protection strategy already in place or planned to manage other workplace hazards. Then the approach can be graded. First, by selecting a reference level, reflecting the distribution of exposure. In most cases, it would be on the order of a few millisievert per year or less. In some cases, it could be above, but rarely exceeding 10 millisievert per year. The graded approach is also by selecting appropriate protective actions. First, using collective protective actions, which are related to the workplaces and working conditions, and then, as necessary, using individual protective actions related to each worker. And furthermore, all the action could be more or less thoroughly implemented, depending on the case. For the protection of the public, we have almost the same approach, starting with the characterization of the exposure situation in order to determine who is exposed, when, where, and how, and with different steps. Then we have to optimize the protection within a graded approach through the control of different segments of exposure. I mean exposure to discharges, to waste, to recycled residues, including building materials. And in this process, we have to select a relevant reference level. And generally, it would be of the order of a few millisievert per year or less. And the stakeholder should be involved in this process. About the protection of the environment, we have the same scheme. The source of the exposure to the environment may be discharges and residues. And first, an integrated approach is recommended, integrating all hazards, radiological and non-radiological hazards, integrating all impacts, human and ecological, I mean non-human species. This approach should also be graded, starting with a generic assessment. If we see that an environment may be at stake, we make a specific assessment, and in some cases, a detailed environmental impact assessment may be necessary. And the use of tools developed by ICRP, notably in publication 124, I mean the concept of RAPS, the reference animal and plants, and the criteria of DCRLs, the concentration dose consideration reference level, may be used as appropriate. And again, we should involve the relevant stakeholders. It is my last slide related to radon exposure. The publication 142 is related to publication 126 devoted to radon exposure. However, many provisions from publication 126 has been integrated in the publication about norm in order to be self-standing. Here are the main provisions. The management of radon exposure should be as far as possible managed at the level of the building, whatever its occupant, workers, clients, members of the public, whatever. It is recommended to set a national action plan and to use a unique reference level selected in the band between 100 and 300 becquerel per cubic meter. And because building materials may be a source of radon, it is recommended to set a list of building material at stake and to provide relevant information to the professionals who are concerned. Then we have a graded approach. As far as workers are concerned, the first step of the graded approach is to manage radon exposure at the level of the building as said previously, using the reference level selected in concentration, in becquerel per cubic meter. If we cannot maintain the concentration below the reference level, then we can use the reference level set in dose, and it is recommended to use a value of the order of 10 millisieverts per year. If the dose cannot be maintained below this reference level, then there is a room to manage workers as occupationally exposed. And then it appears in two cases, either if the reference level in dose is exceeded, but also in some activities and facilities set in a national list and for which it is from the outset considered that workers are occupationally exposed. Last but not least, ICRP recommends to manage radon and other radiations exposure separately by pragmatism. I thank you very much for your attention.